students, welcome to notes. We are on page 20. This is type 2 ionic. Please take a little bit of time to get your header on your notes filled out so you are ready to go and you have it all there. So jumping right in. If you didn't hit pause, please hit pause now and get that down. All right, jumping right in, we are going to talk about type 2 ionic. Last week, or last time we had notes, we talked about type 1 ionic notes. And now we are going to talk about type 2. These are still ionic compounds. So it's still a metal and a nonmetal that is bonded together. The difference is that we don't know the charge on the cation. So we have to figure that out. So it requires a little extra work for us. So let's first go with what are the Roman numerals that we are going to use. So a quick review, hopefully you know this already, our Roman numerals. For 1, we have the I, the capital I. For 2, II. 3, III. 4, IV, and so on. Hopefully you can read those. I don't need to hopefully go through all of those, but they are right there for you. They'll always be there for you. So let's jump into the steps for naming, and we kind of have an aside that we're going to hit in just a couple of seconds. So our first step says that we need to find the charge of the cation. This is probably the biggest challenge for students when they are trying to figure this out. So we have a couple of examples down here in this box. On your notes, you most likely don't have it, so add this box somewhere where you have a little bit of space, and we will jump right in. So to find the charge of the cation, what we have to do is we have to figure out or use the anion to figure out our charge. And remember, our charges, we're going to add them up to be 0. So if we look at this, we know oxygen is -2. I found that on my periodic table above group 16. It's a -2 up there. So remember, our charges have to add up to be 0. So looking at this one, it's pretty simple. What does each iron, since there's only 1 and 1, right? We all understand that there's 1 iron, 1 oxygen. That's understood when they're not written. What does each iron have to be if oxygen is -2? If you said +2, you are correct. So iron in this case is going to be +2. In this case. But in a different situation, it might change. For instance, look at the next example. This time, we still know oxygen is -2. We have 1 oxygen, but we have 2 irons. So, looking at it this way, think about it in terms of this. We have 2 irons that have to add up to be +2, if you will. So when they add up, they'll be 0 plus 2 minus 1, or -2 gives us 0. So what does each iron have to be? They have to be the same thing. So what does each iron have to be? In this case, each iron has to be +1. So in this case, iron is +1. So you can see that it's going to change, which is why we have to signify what the charge is. So let's move on from that little aside, and let's go to number 2. Write the name of the cation. We're going to add the charge of the cation in a Roman numeral and in parentheses, right? We'll have parentheses around it. Then we'll write the anion name with the "ide," or if it's a polyatomic ion, we will just not change the name of the polyatomic ion. That's the same as type 1 ionic. So let's see if we can't do an example here. So our first step says that we're supposed to find the charge of the cation. So we have CuO. If O is still -2, just like it was on the aside, what does each copper have to be? Each copper has to be +2. So we know copper is +2 in this situation, so we're going to say copper. Then we're going to put Roman numeral 2, II, and then we're going to say oxide. So the correct answer here is copper 2 oxide. Awesome, let's move on to the next one. This time, we have iron and nitrate together. We know each nitrate is -1. We can find that on the top of our periodic table. So if we look at that, kind of breaking it down in terms of like breaking it down into each little piece, we have 3 nitrates, and each nitrate is -1. So each one is -1. That gives us -3 overall. So iron has to be +3. So each iron has to be what in this case? It has to be +3. So we would say iron, 3, I, and then nitrate. The pen's getting a little thick there since we're going so small. Let's see if I can't resize that a little bit. There you go. We'll take it down just a notch. All right. Let's look at our next one. This time we have Mn. Let's change our color a little bit there. Just get us a little different color. All right. So we've got Mn, manganese. And if we look at our first element tells us it's type 2. We should have colored this one in like type 2. So we know we have manganese, and we have 2 of those, and we have 1 sulfur. Each sulfur is -2. So each manganese has to be +1, which gives us a +2 overall and a 0. So in this case, we're going to say manganese 1 sulfide. Notice how the anion part is exactly like it was for type 1. That did not change. So the only thing that's different is we have Roman numerals. Okay, so let's roll on and do this last one. I want you to try this last one on your own. I will give you a couple of seconds and then I will work it very slowly after you. So please take a little time to work this one on your own. So hopefully you came up with gold 3 and then sulfite. Hopefully that's what you came up with. All right. If you have questions, go back and watch the video as kind of I played it. Just go ahead and do a quick rewind there. All right. Let's roll on here. We are going to talk about steps for writing formulas. This is the exact same thing as type 1. The only thing is now we have our charges of our cation given to us based on or from the name. So if we look, we're going to write our symbols, we're going to add charges, we're going to crisscross and reduce. Super simple stuff, just like we did in type 1. So the first thing, we've got titanium 1 oxide. So we have titanium. Then you look at like titanium on your periodic table and you're like, Miss Griffith, that does not have a charge listed above it. Well, that's why it's a type 1. So we know it's +1 based on that one right there. So titanium in this case is +1. Then we have oxygen, which is -2. So we have to do our little crisscross, right? We'll crisscross 2, 1. So we should get Ti2O. All right, awesome. Let's try another one. This time we have uranium, and it says it's +6. Ooh, that's a big one. All right, and then we have sulfur, and it's -2. So when we do our crisscross and reduce, we take a 2 down. It's a terrible 2. And take a 6 down. All right. Now we have U2S6. Is there something we can reduce out of that? Yes, we're going to say US3. All right. And let's do our last one. This time we have not U. Do a little erasing. 10. We have SN. It is +2. Remember, it came from that 2 right there. Then we have sulfate, which is SO4, and it's -2. If you're like, hey, Miss Griffith, I already got this. They are going to crisscross and reduce. You are correct. It's SN SO4. I say great work, and see you on the next one.